Dear learners, welcome back to NPTEL online certification course on novel drug delivery systems. I am Dr. Satish Devanapelli, Assistant Professor at Department of Pharmaceutical Sciences and Technology, Institute of Chemical Technology, Mumbai. In our novel drug delivery systems, we have started with the topic of transdermal drug delivery systems. In that, in our previous classes, we have discussed what are the transdermal drug delivery systems, and then we have seen what are the ideal properties, and then we have discussed on the advantages and limitations, and also we have seen where we can use such systems for the treatment for the humans. And also we have discussed what are the factors which will influence the bioavailability of the and therapeutic efficacy of the transdermal drug delivery systems. In our previous class, we have discussed the components used in the transdermal drug delivery systems. There we have discussed on the properties which are required for a drug to convert into the transdermal drug delivery systems, and also we have seen what are the polymeric matrix and its importance and role in the development of the transdermal drug delivery systems. And after that we have seen the importance of skin penetration enhancers to overcome the barriers of during the administration of the transdermal patches. And then we have seen the role of pressure sensitive adhesive, and we have seen the importance of rate controlling membranes in the delivery of the transdermal patches, and also we have seen the importance of the backening laminate, and then we have seen the other components. So, today we are going to discuss on two topics. The first we will see what are the types of the transdermal patches, and then we will see the permeation enhancement strategies for transdermal drug delivery systems. So, based on the rate programmed systems, these transdermal patches can be classified into the 4 categories. There are the references which you will see, there are the published literature and reports suggest that. You will see sometimes only 3 classifications. These 2 things, some of the authors are combined into one systems. But anyhow, today we are going to discuss on the 4 different types of the transdermal patches. So, first is reservoir system, and second thing is the drug in the adhesive systems, and then the drug in the matrix system, and the drug in the microreservoir systems. In the second class, the drug-in-adhesive system, which is further classified into the single adhesive layer and multiple adhesive layers. So, here is the picture representation. So, the first we have seen, that is the reservoir systems, and then we have seen the adhesive things, and then matrix, and then micro needles. Now, you can see what are the color indication for all these materials. Now, here you can see this is stratum, corneum, epidermis, dermis and hypodermis. The ultimate goal to reach the drug into the skin and then further into the systemic circulations. And here also one more approach, that is the microneedle. Yes, that is also can be translated into the patches. So, these are the 4 are the conventional transdermal patches systems. Now, you can see in single adhesive in patch, you will see only one adhesive membrane, that is single layer, which contains the drug. Here you can see this place, but whereas here you can see 1 and the 2, and in reservoir the drug is loaded in the reservoir system, whereas matrix it is a combination of both like polymer and the drug. So, drug is encapsulated or matrixed into the polymers and further microneedles. We will see one by one. So, here you can see the pictorial representation of the reservoir system. So, as we know in last classes we have discussed on the various components of the transdermal patches. So, you can see the topmost, that is impermeable backing layer, and then you will see the second one is the drug reservoir, and third one is the rate controlling membrane, and the fourth one is the adhesive. Now, here you can see when you load your drug between impermeable backing membrane as well as between the rate controlling membrane, which is called as a drug reservoir, where reserving the drug between two layers. So, you can see that, you can read it here. So, drug reservoir between backing layer and between the rate controlling membrane. So, that is why it is called as a drug reservoir. So, drug is placed in between the two things. So, that is why it is a name, it is called as reservoir systems. Now, here drug can be in the solution format and the suspension, sometimes gel, or in the combination of semi solids also possible, and also mixing with the various types of the solid polymers. So, that is also possible. So, what we can predict with this? So, when you use such drug reservoirs, we can maintain the controlled release because of that polymers which rate controlling membrane will control, and the reservoir slowly release the drug from the through diffusion mechanism. So, through microporous and non-porous membrane. And yes, because you can load high amount of drug, because you can see by seeing the picture representation also the reservoir capacity is very high. So, with that we can expect high drug loading, and here you can see the possibility of drug leak is also possible, because we are not giving any polymer to load or encapsulate your drug into the system. So, now the second case is we are able to load the drug in the some of the component. Now, you can see here the component is the adhesive system. Now, we are taking the drug and we are mixing into the adhesive system. So, here it works as a dual system. It will work as adhesive, also it is helping to encapsulate the drug in the adhesive systems. Sometimes it may be single systems and multi layers also possible, right. As we can see, the single layer also possible, multiple layer. You can see here the pictorial representation, and if you want to know further, you can see this reference, and you can see the outside, that is a backing layer, and here is the liner that we need to remove, and here we load the drug which is only single layer. You can see the drug is dispersed uniformly into the single layer. Now, if you need, like if you want to increase the dose, right, and in single case your drug dose is not sufficient, and now you want to see multi layers. So, what we can use? You can use some membrane, replace, and you can multiply or you can increase the dose in a single system, right. So, here you can see the multiples, it may be 2 layers, 3 layers and 4 layers based on the need of your requirement. And yes, the drug is uniformly dispersed in the adhesive polymer. So, top protection layer also possible. A non-medicated adhesive layer may be added on the top, that we have seen here, and for the protection and for the control release. And the third system is matrix dispersion system, or you can say matrix diffusion control systems. So, these are the interchangeable words. Now, you can see these arrangement or the components are arranged in completely different compared with the previous two systems. Now, you can see the uniform drug dispersion, the drug is homogeneously mixed with the hydrophilic and lipophilic polymeric matrix. So, here we use the hydrophilic or lipophilic or hydrophobic polymers, we will make a matrix system. So, our drug will be encapsulated into the polymer systems. So, definitely the control release will be very higher compared with the other two systems. Now, you can see the pictorial representation of this patch. So, here you can see this is the drug reservoir. So, here you can see the drug and polymers looks in a matrix system. So, which is embedded into the polymer system. Now, here you can see there is a adhesive rim. So, here we need to adhere our patch, and after that you will see one more layer, that is the adhesive base plate. There we attach our adhesive rim, and then after that you will see the adsorbent pad, and then after that you will see drug impermeable backing layer. So, this is the way we need to arrange the components, or we need to prepare the transdermal patches by using the matrix dispersion. So, you can see in the theory also here, matrix is placed on the occlusive base plate, that is non-permeable backing membrane. So, once your patch is developed, that you can attach to this adhesive rim, and then that will act as a drug reservoir and it will control the release. And now, this adhesive rim will help to adhere our patch, as well also we can put directly contact with the skin. So, adhesive is not on the drug layer, but around the edges, forming an adhesive rim to hold the patch. So, this will help to hold the patch, whereas in previous cases we will see there will be adhesive layer always in the outside. Now, you can see in the reservoir system. So, here we have the adhesive layer, right, and here also some of the membrane will be there. After the liner, we will remove the liner, and here also adhesive membranes are there. With that we can attach to the skin, but whereas here the outside, whenever in contact with the skin, you will not see the any adhesive membrane. So, this will help to adhere to the skin. And direct skin contact, the drug containing matrix is in direct contact with the skin, that will allow the diffusion of the drug. So, this may directly will contact with the skin, there is no barrier of adhesion systems. Now, the fourth one is, these are the some of the new innovations which are happening in the transdermal patches. Now, we know the reservoir systems. When you take any drug and will disperse in a polymer, it will become a reservoir, or will encapsulate drug into the some polymer, it is called as a reservoir. Then what is the microreservoir? Taking off that drug loaded or encapsulated polymer solution into the another system, right. So, that is called as microreservoir system. Now, you can see the picture representation. So, here is the particles which are the microreservoir systems. Now, you can see the pictorial representation here. So, you can see here there is a drug crystal that is encapsulated with the water soluble polymer, and after encapsulation, so this drug loaded water soluble polymer system we further disperse into the lipophilic polymers. So, this is called as microreservoir system. Now, such systems will follow the zero order drug release, and that will release the drug at steady and constant rate throughout the treatment. So, here these are the impermeable backing layer, and this entire system is drug microreservoir. So, here what we are doing is that, so here is the first reservoir, and after that we are taking that water soluble polymer into the another system. So, this is called as micro reservoir systems. So, with this you will get high controlled release compared with the reservoir systems. So, here also you can read the drug is first suspended in aqueous solution, that is water soluble polymer, further solution is dispersed in lipophilic polymer forming thousands of non leachable micro reservoirs. So, with that we can expect the zero order release. Now, we are moving to the second topic in this. So, that is permeation enhancement strategies. So, again you will see lot of references for this topic, but based on the some existing literature and with the highly impacted paper which we have selected for the reading. Now, this can be classified based on the first generation and the second generation and the third generation. But today we are going to focus on our classification based on these enhancement strategies rather than the classification. So, if I cover this, you will definitely understand what are the further advancement happening in the second and the third generation. We are going to see very detailed in the various enhancement strategies. Now, the first generation is very well says that no patch system, that means liquid sprays, gel, cream or the topical, which is nothing but the conventional transdermal formulations comes under the first generation. Yes, definitely we know they have the limitations. That is why scientists have developed various strategies by taking off such general or generic or conventional formulations. People have improved the permeation of the transdermal drug delivery systems. So, the first system we can see here the drug vehicle systems, and here we have the two major components which is. So, here you can see in the first point drug vehicle interaction. So, here the vehicle or you can say any agent, any substance will help for the permeation that will interact with your drug. So, our aim here in this particular topic ultimately to improve the permeability through the skin. So, that is the main purpose, increase skin permeability without damaging the deeper layers. So, these are the drug vehicle interactions, they will not damage the skin layers. So, here the first approach is the prodrug approach. So, we know that. So, the single drug which cannot pass to the biological membranes, also the solubility also one of the major issue. But here you can see in this case when you attach your drug with some other substance, so that will help for the solubility as well as the permeability, and not only that other ADME profile also will be definitely changed compared with the plain drug or free drug. So, the drug need to be linked with another molecule by covalent bond. So, makes the drug more hydrophobic, that will passes the lipid barrier which are present on the stratum corneum, and after absorption the prodrug is converted into its active form. Now, you can see this prodrug, it is passing the cellular barriers and it is entered. After that the biotransformation, nothing but the carrier or vehicle will leave and only drug will follow further its action. So, these drug vehicles which will carry the drugs from the site of administration to the therapeutic action. Here we have one more system, that is ion pairing method system. So, here specifically we use the ion based drugs which cannot passes through the stratum corneum, and there are the lot of permeability issues. So, here what we do, we use counter ions. Here it is the positive charge and we are using the counter ions which have the negative charge and which contains also hydrophobic groups. So, this is called as ion pairing. So, taking off hydrophobic molecules and attaching to the charged groups which is negative, and this further will have an interaction so that this hydrophilicity can be modified, and that becomes neutral ion pair that can easily penetrate to the skin compared with the plain drug or free drug. So, once it is entered, that will dissociates and the drug get absorbed. Now, you can see, so these are the hydrophobic molecules will interact with the lipid membrane, which will help for the permeation. Now, the vesicles and nanoparticles we know, we have discussed very detailed. So, various types of systems can be used. We have learned even the ethosomes also, how it works in the penetration of the skins. Also, we have seen the transferosomes and liposomes in our novel drug delivery systems, because here we use various types of the ingredients, especially in case of ethosome we use ethanol, it works as a penetration enhancers. Even in the liposomes we use various types of lipids, and also there are the formulations we use surfactants, co-surfactant, which ultimately help for the permeation of the nanosystems. And not only that, the size of the particle is very less. That is why which can easily cross the various types of the cell or skin barriers. So, with that we can improve the drug absorption. Now, here we have the stratum corneum modification systems. We already discussed this in detail in the factors influencing the drug permeation. So, there we studied the skin hydration is very required, and that will ultimately helpful for the permeation. So, here we can use occlusive patches or dressings which will trap the moisture, and also we can use lipid excipients. Humectants also provide the moisture or water content to the skin. And then chemical penetration enhancers, this already we have discussed in detail in the ocular drug delivery systems, and we have discussed how it works by using these three mechanisms. It will disturb the lipid layer, it will alter the protein structure, also modify the drug partitioning into the skin. So, you can also refer the previous lectures, there we have discussed on the chemical permeation enhancers. Yes, definitely the toxicity and skin irritation ultimately depends on the concentration of the surfactant, and yes, cationic have the highest toxicity compared with the other types of the surfactants. So, these are the various chemical permeation enhancers. So, these are based on the classification. Now, you can see the pyrrolidins, azones, sulfoxides, terpenes, urea and the surfactant. These are the most commonly used, and the alcohol also people use in the various applications. So, here you will see, so lot of the mechanisms, this will also will help to select, so which type of the permeation enhancers. So, most of the cases you will see which is discussing on the like protein, and also it will denature the protein, and also it modify the drug partition, right. So, and also it will extract the stratum corneum lipid, and it interact with the lipid. So, these ultimately the three mechanisms are very important for the modification of the stratum corneum. And the fourth one is the energy driven methods. So, here in energy driven method we have so many techniques. So, the main focus here will do the external, will apply external energy or some physical instrument or tools to enhance the drug permeation. So, here we have ultrasonic energy, velocity based, here also it is also known as sonophoresis, also known as phonophoresis. Velocity based, these are the jet injectors, and here you can deliver the liquids as well as powders. The electric methods, electroporation is one of the great technique, and even ionophore is also specially designed for the transdermal patches, and people also use for the other types of the formulation, especially ocular also. Thermal and the mechanical methods, the microneedles that we will focus, the rest are the minor part that we are not going to discuss. If you want to know more, so this is the open access paper, you can read and refer for the further studies. So, here we will see only pictorial representation, and we will discuss some of the advantages of each system. So, now you can see here, so these are the ultrasound, sonophoresis, phonophoresis. So, here the ultrasound energy will help for the skin permeation. So, what is the principle? It will create the cavitations that will allow the formation of the microbubbles that will disturb the stratum corneum. Now, you can see the power supply, ultrasonic inducer, probe, and you can see the ultrasound waves and the bubbles which is represented in the blue color and the drug molecules in the light yellow color. And now you can see the disturbance happening after the supplement with the ultrasound. So, that will help for the permeation of the drug molecules into the deeper layer of the skin. Now, second is velocity based device. So, here you can see it is also known as the needle free injection methods. So, here we will supply or will provide our formulation in the powder format or in the liquid format with the high speed, so which can be worked by the compressed gas and the springs which will deliver the drugs into the deep layers of the skin without having the needles. Now, you can see the normal injections which may be intradermal or you can see intramuscular, right. So, the needle need to be passed into the deeper layers and then will give the injection through the syringe. So, here you will feel the pain, but these systems you can see here, these are the injectors. We need to load the drug and just we need to inject without having pain, and there is no needle which will give the pain to the patients. So, that is why it is called as pain free, needleless, safe administration. Also, self administration is possible. Now, you can see the comfort in the needleless injections. So, here especially in case of insulin, some of the vaccines you can be used for the treatment of the various diseases. Now, electroporation, now the term itself speaks that here we use electricity that will induce the pores. So, the voltage will help to open the pores of the skin for a temporary applications. So, it looks, the picture looks like a similar to the ultrasonication, but the working mechanism is completely different. So, here the pulse waves can be produced, and of course, the mechanism is same and the energy is different. So, you will see the disturbance in the stratum corneum that will help for the creating the electroporosis, ultimately which will enhance the permeability. Now, here you can see the iontoporosis. This is also we use for the charged molecules, and when you have a problem of the delivering of the charged molecules or some of the neutral molecules into the skin, here we apply electric field. So, these already we have discussed in detail even in the ocular drug delivery systems, in the novel ocular drug delivery systems. So, here when you want to transfer positive drugs from the, when you want to deliver the positive drug to the site, you can use anode. Anode will repel all type of cationic drugs and that will reach to the target site, similar to the with the cationic anionic drugs also. Now, you can see here this is a device which is available in the market. So, this drug reservoir, that is anode, which need to be placed on the skin, and here is the cathode, okay, and the drug will diffuse from this and it will go to the controller and then it will go to the target site. So, with this we can develop various types of the novel transdermal drug delivery patches also. And microneedles, this already we have discussed again in the ocular drug delivery systems. You can refer previous classes also. So, as we discussed, microneedles are the micron size needles which have a solid support, and this needle height ranges from 25 to 2000 micrometers. So, here you can bypass. So, the word is very important, we can bypass all type of the stratum corneum barriers. So, because it works as a needle, it can penetrate into the deeper layers of the skin, which will deliver the drug. Of course, the cost is very high compared with the conventional formulations. So, these are the 5 types of the microneedles which will help to overcome the conventional transdermal patches. So, this already we have discussed. Again, the usage and the function and the mechanism of the 5 types of the microneedles in our ocular drug delivery systems. So, here we have a solid, coated, hollow, dissolving and hydrogel forming microneedles. So far we have discussed the various types of the transdermal patches. Also we have discussed the permeation enhancement strategies for the transdermal drug delivery systems. So, in our upcoming classes we are going to discuss on the evaluation of transdermal drug delivery patches, and also we will discuss some of the interesting topics on novel drug delivery systems. Thank you so much.